In this video lesson, we will be looking at the linear and angular velocity of objects as it relates to our precalculus course. Linear velocity is measured as a change in distance over a change in time. Common units of measure that we use are kilometers per hour, miles per hour, or meters per second. It's the speed that an object is traveling in a straight line. So if we have a radius of a circle and we want to essentially look at how it goes from one point to the next, we are measuring the linear velocity of that object. Angular velocity, on the other hand, is a change in rotation over a change in time. The common units of measure here are radians per second or revs per minute. This is measured through the speed through which an angle is rotating. The two formulas we will use are listed below. We will now take a look at two examples. In the first example, we are given the angular speed to find the rotation in revs per second. The linear speed that we are looking at, the angular speed that we are looking at here is measured by 3 pi over 2 radians per minute. Let's go ahead and find the angular speed. So given the angular speed is 3 pi over 2 radians per minute, we will now convert that to revolutions per second. So we will use a series of ratios to do our conversions. The first conversion is going to convert from radians to revolutions. To do that, we will use the ratio for every 2 pi radians, we have 1 revolution, or for every revolution, we have 2 pi radians. In the second ratio, we will use for every 1 minute, there are 60 seconds. This will convert in revolutions per second and allowing our radians and minutes to reduce. So through a series of multiplications of numerator and denominator, we get 3 pi. Notice the radians reduce, minutes reduce, and we're left with revolutions. In my denominator, if I multiply 2 times 2 times 160, times 60, we get 240 seconds. Reducing this ratio, we get pi. Oh, my apologies, pi did cancel out here as well. Let's go back and just erase that. So we have 1 over 80 revs per second. In the next example, we will find the radius when we know the linear velocity and its angular velocity. Again, one thing to take note of is we do have different units of measure, so we will have to convert to 1 unit of measure. I will convert to minutes. And on the second hand, we also need to make sure that our calculation for our angular velocity is in terms of radians per minute. So let's start with the linear velocity of 24.8 meters per second, and we will convert that to minutes. So we'll multiply by 60 seconds over 1 minute, and that will leave us with a linear velocity of 1,488 meters per minute. For the angular velocity, we'll take the 120 revs per minute and convert that to radians per minute. So for every 2 pi radians, there is 1 revolution. Multiplying this out, we will get our angular velocity equal to 753.6 radians per minute. I used 3.14 as my equivalent to pi. If you use more digits than 3.14, the answer will be slightly off. Now we're going to solve for r. Using the formula for linear velocity, theta over time being represented by the angular velocity, we can now replace what we know and solve for the unknown, and the unknown is r. So here I have 1488 meters per minute is equal to the angular velocity in rads per minute now. And we're going to multiply that by r and solve. If you divide by the 753.6, r is approximately 1.97 meters. I hope you found this video helpful in understanding and converting using angular and linear velocity.